Hello learners, welcome to this course on embedded system design using PIC16F877 microcontroller. In this tutorial, I will be discussing about on how to interface a 7-segment display with the microcontroller. So a 7-segment display is an electronic display device which is used for displaying numbers. It is mainly used for displaying the numbers. So it is made up of LEDs. So there are 7 LEDs which is used in displaying numbers. So the LEDs are named as A, B, C, D, E, F, G, and there is also one more LED which is a decimal point, DP. So which is used for putting a dot. Whereas for number displaying, we use this 7 segments A to G. So in order to display 0, we have to enable A to F, whereas the G LED will be in off state. To have a number 1, we need to enable B and C segments, whereas all the other segments will be in off state. To get a number 2, we have to enable A, B, D, E and G. F and C will be disabled. So like that, depending upon what number we have to display on a 7 segment, we have to enable the corresponding segments. So the 7 segment, it comes in 2 forms. One is common anode type and common cathode type. So here on the left, I show a common anode type where the anodes are connected, anodes from all the segments A to G and also the decimal point DP are connected to a supply, whereas the ground line of the LED for all the segments needs to be driven with the help of a microcontroller. So the anodes will be connected to a common supply and the cathodes will be driven by a microcontroller. So that is why the name it is called as common anode. There is another version of a 7 segment which is common cathode type, where the cathodes of all the segments are connected together and it is connected to a ground. And from a microcontroller, we need to give a logic 1 to the anodes to enable a particular segment. So here the cathodes are connected together to a ground and a logic 1 from a microcontroller given to the anode of this 7 segment will enable the corresponding segment. So if I connect the 7 segment as it is to a microcontroller, I might require 8 IO pins. For 7 segment A to G, I require 7 pins, and also for a DP, I require one more pin, which is 8 pins. So 8 GPIO pins will be utilized. So in order to reduce the number of GPIO pins, we can make use of a driver IC. So here the driver IC which I am going to talk about is IC74LS47. In short form, we can call it as 7447. So this is a BCD to 7 segment driver. So it takes the input in terms of a BCD number and it gives a 7 segment output. So here the decimal point will not be considered. So here only the 7 segment output will be obtained from this 7447 IC. So if I see the pin details, so it is a 16 pin dual inline package IC, where this A0, A1, A2, A3 are BCD inputs and the corresponding 7 segment output is obtained from pin number 9 to pin number 15, A to G. And the power supply line is 16 and the ground line is 8, and we also have some 3 test lines, which is LT, which is lamp test, RBO is ripple blank output, RBI is ripple blank input. So these 3 are test signals, and this will be an active low signal. If I don't want to use this, we can connect this pin to a logic 5 volt. So what is the interfacing diagram for this BCD to 7 segment driver? So here you can see the interfacing diagram. So where this ABCD is a BCD input, it comes from your microcontroller, and the corresponding outputs A to G is given to a 7 segment display. So here we are trying to use a common anode type. So the common anode terminal is connected to a 5 volt and A to G will produce a logic 0 to enable a particular segment. Since all the segments are made up of LED, in order to reduce a current, we use a resistance of 330 ohms. And the lamp test signal RBO and RBI, since we are not going to use it, we have connected this lines to a logic 5 volt. Since these are logic low signals, a logic low will activate these inputs. Since we are not going to use it, we have connected these lines to a supply. So in this application, what we are going to do is, we are going to connect a 7 segment display to a microcontroller with the help of a IC7447 BCD to 7 segment driver. So I am going to use port B, lower part of port B, RB0 to RB3. So this RB0 to RB3 will provide the BCD inputs and the corresponding 7 segment output will be obtained from the IC7447 and it will drive your 7 segment display. So here I show a table representing a decimal digit 0. Its corresponding BCD input is 0000. If I use a common cathode 7 segment display, in order to get a 0, we provide A to F to be logic 1 and G to be logic 0. So all the A to F will be logic 1 and the center part is your G. So the G will be in off state. If it is a common anode, this will be just reverse. Common anode display in the sense, we have to provide 0 from A to F and G will be 1. So just an inverse operation. So this table is for common cathode, just inverse of this A to G pattern will be for your common anode. So for this application, we will be using Micro C Pro for PIC as an integrated development environment, where we will be writing our embedded C program, convert that embedded C program into a hexadecimal file, and then we try to make use of a Proteus 8 Professional as a simulator, where we give the inputs and try to see the corresponding outputs. So now let us go to the Proteus environment and let us discuss about the circuit diagram. So this is a circuit built on Proteus 8 Professional. So here I have taken PIC16F877 microcontroller, where the oscillator lines are connected to a crystal and to a capacitors. So the crystal is used for providing the clock frequency for the microcontroller, and this capacitor is for providing a stable clock frequency. And there is also a reset circuit here, which is connected to a MCLR pin, which is an active low pin. So whenever I close the switch, what happens? A logic 0 will be applied to this pin, thereby the microcontroller will go to reset state. If I release this, a logic 5 volt will be given, so reset operation will not be performed. And as I said, port B, RB0 to RB3 is going to provide the BCD inputs. It goes to the A, B, C, D input of your 7447. And it generates the corresponding 7 segment output, and it is connected to a 7 segment display. Here I have used a common anode 7 segment display. So the QA to QG will produce a logic 0, thereby enabling a corresponding segment. And you can see the test signals like lamp test, RBI and RBO are connected to a supply. Since we are not going to use it, we have just connected it to a supply. So this gives the circuit diagram. So where I take a microcontroller, connect the oscillator circuit, reset circuit, and the 7 segment driver with the display is connected. Now let us go and discuss the program. So program is written using a Micro C Pro for PIC IDE, integrated development environment. Since we have connected our 7 segment to port B, I need to initialize it to output port. So in order to do that, I give TRIS B. TRIS B is a data direction register for port B, and it is set with 0x00, which means all the port B pins are configured as an output pin. So after saying that the port B is used as an output port, I am going to write the logic. So in a while of 1, first I am going to give 0 0. After 1 second, I am going to send 0 1. Again after 1 second, 0 2, 0 3, 0 4, 0 5, 0 6, 0 7, 0 8, 0 9. After 0 9, again it is going to come back to the 0 0. So here, since we have connected the summon segment to only the lower part, so we have to consider only the lower portion. So lower portion, this is the BCD inputs: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the BCD inputs. When these inputs have been given to your driver, it provides the 7 segment output. Thereby we can see a display. So once we have written the code, we can compile this code by just running a build operation. Build. So program gets compiled and X file will be generated. Now let us go to the Proteus environment, upload that X file. So right click on it, edit properties, select the program file. So the program file is bcd to 7 segment.x. So the hexadecimal file we are going to import into the microcontroller, and we also set the clock frequency to be 20 megahertz. Press OK. So now we have imported the hexadecimal file to the microcontroller. Now let us check how it works. Just by pressing this play button on the bottom left corner, we can see the output. You can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and then again 0. So this, since it is in a while loop, it will keep on continuing. So this is the method through which a simple 7 segment can be connected to your microcontroller. So here we have used this main BCD to 7 segment driver to reduce the number of GPIO pins. If I don't use this BCD to 7 segment driver, then I might require 7 pins for displaying the numerals. If I want a decimal point also, then one more line is also required. So 8 pins will be required. So in this tutorial, I have discussed about on how to interface a 7 segment display with PIC16F877 microcontroller. Thanks for watching. Please subscribe for more technical learning. Thank you.